Alright, I wanted to make a little program to do some 3D graphing. Um, so let's say you had your typical coordinate system with x, y, and let's say you had a point, 1, 2. You could graph that point by moving 1 in the x direction and then 2 in the y direction, and that would be that point, 1, 2. Now let's say you had an equation, f of x, or y equals 3x plus 2. You can just know how to graph this one, or if you didn't, you could say x, y, plug in values for x, plug in values for y, and see what happens. So let's say we had -2, -1, 0, 1, 2, -6, -4, -1, 2, 5, and 6, 7, 8. Then you could plot all these points, and you could continue to plot points in between these values, or in this case we know that it's a straight line, or generally you can kind of see the shape form as you plot points, and as humans we can just connect the dots in between. So this would be well, 1, 2, as you'll see, is not actually on this line, but this could be -2, -4, maybe down here, -1, -1, 0, 2, 1, 5, and then 2, 8 would be off my chart. So that would be a line, something like this. Or we could have just known that it has a slope of +3. So it's 3 off from a horizontal in the positive direction, which tilts the right end up. Or you could know that this is 3 over 1, and it's rise over run, so it's up 3 over 1. So up 3 over 1. And then the +2 tells us that it shifts 2 to the left. It should be, yeah, if we plug in 0, pretty sure it's 2 to the left. 3x minus 2, yeah. 2. No, it's, wait a second. So our y is 0. I wanted where x was 0, my bad. Yeah, which is actually 2 to the right. So y equals 3 times 0 plus 2, or y equals, no, I wanted x. Why did I get 2/3? Sorry, this shifts it up. Up 2. Yes. Okay, so that tells us that we were going through this point right here that I missed, because it shifts it up 2. So anyway, you could have graphed that just by looking at it, or you could have graphed it by plotting the points. Now, let's see. So there's another form of graphing in 2D that's going to be very relevant. There are other forms than 2, but for what I'm going to need to talk about to go over my little program that I made, the program is actually, it's much easier to graph things parametrically. So a parametric equation works like this. As I said, the point 1, 2, let's say that's right here. So that's the point 1, 2. Well, a parametric graph sets x equal to some function of a different variable. Typically t is used, so I'll use t. X equals t and y equals t. and you can write it out like that, or you can just write it in the parentheses, which I prefer to do. So let's say we had 3t for x and t plus 2 for y. So then we make our little chart, x, y, and we do the same thing. We just plug in values for t. So we'll go -2, -1, 0, 1, 2, and then, oops, my bad. We do the same thing, but here we need a third variable, t. So t is what we're going to run through. So we would go -2, -1, 0, 1, 2. Now, when we plug in -2 for x of t, we're going to get -6. I'll just run down through the x's. -3, 0, 3, 6. And when we plug in for y of t, we're going to get 0, 1, 2, 3, 4. And now we can plot these points on our graph, and that will tell us what this equation represents. So -6, 0, -3, 1, 0, 2, 3, 3, 6, 4. So it's a straight line with a gently rising slope. Okay, so that's parametric graphing, traditional graphing, both using charts. Now, so those are easy enough to do by hand, and for parametric, it's easy enough to convert between parametric and standard in most cases. And standard graphs, most people who do any math on a regular basis just have memorized many different forms of functions and what shapes they make, and how different operations that are done to the standard prototype function, how those operations modify the function. So it's not really necessary to make charts usually with 2D functions. With 3D functions, however, I think they're at least less familiar to me. There's only a few that I have memorized off the top of my head, and so it's really nice to be able to graph them. The trouble is, to get a meaningful graph of most 3D functions, you need to run through many more of these little calculations. So my short little charts that I made here just wouldn't cut it. So let's say we had the equation x squared plus y squared plus z squared equals 9, which I happen to know is a sphere with a radius of 3 centered at the origin. But if I didn't know that, in order to try to calculate this, also let me draw the graph here. So typically, this actually drives me nuts, but it seems to be the standard procedure. So this is positive x direction, this is positive y direction, and this is positive z direction, which I think is unfortunate. But so now to make my chart, I would need x, y, z, and you could do some math calculations or just some thinking about your equation before you start filling in numbers to better your chances that the numbers you're picking are meaningful. You can use calculus to do that, or you can use other methods too, I think. But let's just say we wanted to just pick some numbers. So here I have to choose 2 of the columns to calculate the third. So let's say I could run through x's. I'm just going to do 3 this time because it's going to take a little longer. Let's say I did -1, 0, 1, which those aren't very good choices, but just bear with me. This is just for illustration. And for y, let's say I did the same, -1, 0, 1. So now I run through and I can figure out z. And let me just manipulate this. So this is x squared plus y squared minus 9, the square root of all of that equals z. Z is what I'm actually calculating for. So 1 plus 1 is 2. We have negative 7. So yeah, already that was a bad number. I have square root of negative 7, which does exist in a sense, but it will not exist on this plane. Plane's not the right word. It will not exist on these axes. So there's going to be no dot there. 0, 0. I have to pick something bigger than 9 in order for it to show up. So, or at least 9. So let me pick some new numbers, because this is going to be a negative number, square root of a negative number, and this will also be the square root of a negative number. So I have hardly any room. Let me just erase that real quick. Okay. All right, try this again. So x, oh, I made my line smaller. This is the size that I had. So it still made it smaller. Oh well, x, y, z. Now, I'll still just pick 3 sets of numbers, but we know that 9 is going to give us 0 for our z. So let's try 9, 10, 11, 9, 10, 11. So we have 81 plus 81 minus 9. Let's see, 162 minus 9 should be, what is it, 153? I think it's not going to matter a whole lot, because I can't do the square root in my head anyway, but square root of 153, can I approximate that? What would the square root? So 12 is 144, so it's going to be a little bit bigger than 12. And all the rest of these should probably be the same, actually. So 10 squared 100, 200 minus 9 is 191, square root of 191. I think 13 squared is 169, so we'll say it's a, what's 14 squared? I don't know 14 squared. So we'll say this is about 13. It's going to be close. 11 squared, I think that's 121. So 242 minus 9, 233. We'll say that's about 14. I don't know, but it's bigger than 13. It's not a whole lot bigger. Maybe 15. I don't know 15 squared either. So say those are approximate. So we have 9 on the x, 9 on the y. Sorry, this is x. 9 on the x, 9 on the y, and then maybe 12 on the z. Then we have 10 on the x, 10 on the y, and maybe 13 on the z. And 11, 11, 14, it's going to be somewhere up in here. And at this point, you really can't tell what shape that makes. I mean, it looks like a straight line, although I happen to know this is a sphere. It should be centered on the origin, so I think maybe I made a mistake somewhere. But at any rate, my whole point was to illustrate that it is much more difficult to try to just plot the points, because you have a lot more to consider. You have to run through, well, actually, partially just because it's not a straight line, you have to run through a lot more numbers. If you don't already know what the curve is in general, you have to run through many numbers to get the general shape of the curve. And the other point is because there are 3 variables, you have to choose variables for 2 of the columns. So unless you are able to decide which numbers would make good choices for the 2 columns, you may end up going through many, many different numbers in the columns. So basically it's many calculations. So that's where computers come in. They are very good at running through calculations. So let me just show, where's my mouse? Okay, so this is a little, I should switch to my regular mouse for this actually. This is a little program that I made. I'm still working on it, but what I have going is I hard coded in. Actually, I'm going to get my regular mouse because this is going to go a million times faster than trying to manipulate this with a sketchpad. Okay, so I've just hard coded in some, more or less some functions, except I don't happen to actually know what these functions would be when written in a standard form, but someone could just write them as functions, especially as parametric equations. So let's see what happens when the first one that I have set up, when I hit play here. Okay. So this first one that I have set up, what's happening is, my mouse is sticking. So it is going through and creating these balls one at a time. Apparently my computer can't handle the recording software and the game software at the same time. Okay, that's unfortunate. It handles it just fine without my recording software. Basically what's going on is there's all these, it runs through and it plots each one of these one at a time. And in the end, you can see the shape. So what I've made here is a plane that I adjusted and added a sine wave in to what would have otherwise been 0, and you can see it made a wavy sheet, basically. And that's so frustrating. This doesn't normally do that. Okay. Yeah, I can't handle this many. All right, that's because of my my recording software. This doesn't usually mess up. All right, so back to my coordinates. Let me show you. This right here is what's being run. And basically all it is 2 for loops. And if you imagine this happens to not be the same equation I just shown, because I haven't gotten it to be able to graph a sphere yet, but it is a different equation. And what the for loops do is basically they run through values for z, they run through values for y, and then they plot. And I think I don't, let's see. Currently I only have 2 variables, so it would be more like a parametric equation where you have x equals some function of, so you have x of t, then maybe y of t, then like z of p or something, some other variable that it runs through. And that's how it's working. So I set it up with i's and j's, and I have the x coordinate running through I, just flat out I, the y coordinate running through j, the z coordinate is actually running through sine of I, which is where that wave is coming from. And if I change that to a 0 or even a number, it would make a flat plane and put it wherever I have it. All right. So once again, now you'll see this is a perfectly flat plane, and it is centered. The white axis there was my origin, which it is completely covered because it is centered on the origin. The size of the plane is because of the amount of iterations I have going. And yeah, so there's that. Once it stops freezing up here. All right, now just show a couple more. Oops. Comment out this one and uncomment. So this one is a donut shape. So this is graphing a circle, and it's graphing a circle, basically a 2D circle in 3D space, and the whichever variable I leave as just a plain number or as a 0 is the axis that the circle is on. So right now I have x equals to 5. So if it were 0, it would be on the zy plane, but since it's a 5, it is 5 units along the x-axis out from the zy plane, which you'll see in just a second. Once it's done loading. Hopefully this is a much smaller, simpler graph, so it's not going to slow down my computer. So you'll see it is a circle, and it is 5 units in the positive direction along the x-axis, and this shape lies on the YZ plane. This is Y. This is Z. These axes up here are wrong. Unity uses these axes naturally, and I switched the axes to the standard convention that I'm used to seeing. So these labels are incorrect. Vertical is Z, towards the camera is X, and then left and right is Y. The other thing is this is technically an actual circle as opposed to a donut. The way that I have this graph working, it's every time it runs through an iteration, it creates a sphere at the location, and the location where it creates the sphere adjusts according to the equation that I gave it. And in order for it to actually look like, basically to connect the dots, I have a relatively large size sphere, which is why it created this donut shape, but technically the graph is actually producing a circle. So yeah, there's that one. Let me just show one more real quick. And this one is actually completely not interesting. This is just a straight line, and for this one I actually have a true parametric equation. So it's x, y, z. It's a three-dimensional parametric equation, but x, y, and z are all functions of t. So I have x equal to 4t plus 1, y is equal to 3t, and z is equal to 0. So let's see what that produces. As you can see, it's just a straight line. and the Z I set to 0, so there is no motion in the Z plane. So let's see, X, Y, I don't know if I can flip it around that way. That's X, positive. Not gonna let me, there we go. So this is how you would normally view the graph. This being the X plane, or X axis, this being the Y axis, if it was a 2D graph. And it is a straight line that goes on forever. The reason that it starts right here, or stops right here, whichever, is because I graphed it. I had to choose my parameters, and my parameter doesn't extend past this position. So yeah, there's some graphing fun.